Hello, everyone, and welcome to our very first stop on this Metamorphic Extravaganza field trip. My name is Elizabeth Bolin, and I will be talking you through the first 4 stops for this field trip. All right, so stop 1 is located at Ducktown, Tennessee, and this is what you can expect to see at this locality. Unfortunately, there's no fresh outcrops of garnet-bearing rock in the area. It's all highly weathered. And most of it looks like this. It mostly looks like mud, weathered clays. One of the main reasons behind this is the fact that this whole area was extensively mined and suffered the effects of mining for many decades. And you can see artifacts of these mining escapades and whatnot at the Ducktown Basin Museum. Another thing to note here about this particular image is that this is the Burra Burra mine pit. Okay, so this was the main access for the Burra Burra mine workings. All right, so where are we? So we're in Ducktown, Tennessee, which is near the borders of North Carolina and Georgia. And we are in the Great Smoky Supergroup within the Western Blue Ridge. Other notable features on this map include the Murphy Syncline, as well as our other 2 stops that we'll see in North Carolina, which are Winding Stair and Standing Indian. And as we'll see, these are much higher grade metamorphic rocks than those exposed at Ducktown. All right, so how do you get there? So getting to stop 1, if you're coming from Chattanooga, you would just simply take US 64 East. Eventually, you will hit the town of Ducktown. If you head north into Ducktown, you'll find the Ducktown Basin Mine Road. Turn right up this road and you'll hit the Burra Burra, or find the parking lot rather, for the Burra Burra mine viewing point, as well as the Ducktown Basin Museum. The only bit of safety for this particular stop is just stay out of the fenced-in regions. So don't jump fence, don't cut through fences. Follow all the signage and directions given to you by the museum keepers. Please don't access any properties without permission. The Burra Burra mine pit is now filled in with water, and it can be viewed from the museum parking lot. So in the museum parking lot, this is the museum here. It's a small building, but it has a lot of good information. They have details on the mining history as well as the mining methods for this particular area, in particular for the Burra Burra mine. There is a fee to go in and look at all of these things and for a guided tour, but you can also take a self-guided tour as well without paying a fee. We highly recommend that if you visit this place in person to go and talk to them and get permission to go to their dump piles, which are located here in this very glamorous looking back lot. These are dumps of rock or piles of rubble are from the Burra Burra mine pit itself. And they truck these in so people and tourists and school kids can come and collect and see what the rocks look like that came from the Burra Burra mine. The sample that we describe in this field trip comes from these dump piles. So highly recommend perusing these if you get the chance. All right, so a little bit of history about the Ducktown Basin. So copper was first discovered by prospectors at the Burra Burra mine location in 1843. These are copper sulfide deposits that are interpreted as metamorphosed volcanogenic massive sulfides, or VMS deposits, and they're hosted by the Ducktown Formation of the Great Smoky Supergroup. These sulfide ore rocks locally cross-cut stratigraphy and structures and are interpreted as being remobilized during metamorphism. Now this image over here on the right just shows the types of rocks you can expect to find within the dump pile. Some of them are more typical schistose rocks with muscovite, and I apologize for how horrible this rock looks. I promise it's much better in person. This rock also has sulfides within it. The rock here is more interesting from a metamorphism standpoint because it has large garnet, it's got chloride, it has hornblende. This is in fact the sample that we described later on in this field trip. This is the self-guided walking tour pamphlet, which again, you don't have to go into the museum to get a hold of. It is simply located in a little box on the outside of the fence, right at the viewing point for the Burra Burra mine within the Ducktown Museum parking lot. So highly recommend taking this self-guided walking tour. All right, so the current tectonic setting. So the tectonic setting for the Great Smoky Group in the Western Blue Ridge is that it's part of the Western Blue Ridge, and it includes metagraywacke, metaconglomerates, as well as pelitic schists. Within the Ducktown Formation, there are abundant muscovite biotite schists, mostly lacking garnet, with variable amounts of graphite. Garnet and storolite porphyroblast have been reported within the region from both drill cores during the exploration of this area for copper mines, and they tend to coarsen and get larger with proximity to the ore zones. The ore zones within the Burra Burra mine are closely associated with chlorite plus or minus garnet schists, which is that type of schist I showed on the prior slides. So prior work on the metamorphism. The only temperature and pressure constraints are from calcite dolomite and silicate thermobarometry from Nesbitt and Essen in 1982. They determined 540 degrees Celsius and 6 kilobars for metamorphism. In terms of timing of metamorphism, it could be as old as 475 MA, or as young as this biotite argon closure temperature of 435 to 424. Now, it's important to note here that this is a closure temperature, which is basically a cooling time for this biotite. It does not date peak metamorphism. So these 435 and 424 MA ages are simply a cooling age for the mineral biotite. So I mentioned earlier that the ore bodies were remobilized during metamorphism. As a result of this, the timing and pressure and temperature conditions of this metamorphism is of great interest in terms of how these ore deposits were remobilized and at what time. All right, so this is the same sample that I showed on that other slide of that garnet hornblende chlorite schist. This sample is from the Burra Burra mine dumps provided by the Ducktown Basin Museum. And again, unfortunately, there is no outcrop description available. So this is what we have. Luckily, though, this sample has great garnet. They approach a centimeter, but most are much smaller. Most are about half a centimeter. Hornblende are the dark black minerals in this sample. Most of the ground mass, though, around the garnet is all chlorite. There are a few spots of sulfide mineral, so pyrite as well as arsenopyrite within this sample as well. Which brings up an excellent point that if you do visit the dump piles for this mine, please wash your hands before eating or drinking anything or rubbing your face. Whatever you want to do with your hands, just wash them before you do those things, because arsenopyrite could get into your eyes, into your mouth, etc. So please wash your hands after going to the dump piles. All right, so the garnet from this particular sample is oddly shaped. They are subhedral to anhedral. And you'll notice from this image on the right here, this is a concentration map showing elemental concentrations of manganese. And you'll notice that the core of this garnet has brighter or higher manganese than the rim. High manganese in garnet cores and low in the rim are often interpreted as prograde growth zoning. So the garnet in this sample do preserve a prograde growth history. So therefore, if you can date this growth of garnet, then you can determine the age of garnet growth, and i.e. peak metamorphism, timing of peak metamorphism. So that's what we've done. So the UA Rad-Ice Lab has dated this sample using garnet samarium neodymium geochronology, using what's called an isochron method. That's what's shown here on the right. This line connecting all these points is called the isochron. And this method assumes isotopic equilibrium between garnet and the rock. So essentially garnet and all the phases surrounding it. So to walk yourself through this, or to walk you through this and then to know what you're looking at here, on this axis we have 143, 144 neodymium. On this axis we have 147 samarium and 144 neodymium. All the rocks, such as the whole rock, any matrix, mineral, anything not garnet, will plot way down here at low ratios. All the garnet will plot at higher ratios. The more points you have of garnet and rock on these isochrons, the more precise your age will be. So for this particular sample, the slope here defines the age at 449 MA plus or minus 12. And there are 7 points defining this isochron, so it's fairly robust. So this garnet grew based on prograde manganese growth zoning at 449 plus or minus 12 MA. All right, so what's the significance of this age? So this age confirms tectonic peak metamorphism in this area. Now this 449 MA age is between the oldest estimate, that 475 MA for metamorphism, and the youngest cooling age for biotite, argon-argon, which was 435 to 424. Interestingly, as we'll see on at the next 2 stops, Winding Stair and Standing Indian record very similar timing of metamorphism, suggesting that the entire region from here to here experienced the same event. All right, so to put this into perspective in terms of tectonic event or orogenic event, we've included this figure from Mershad et al. 2017, which shows the probability curve and all the different peaks of zircon data, which show the extent of each of these orogenic events. So the tectonic event is centered around 450 MA. Then we have the Akkadian, the Neo-Akkadian, and then finally the Alleghenian. So what our data show is that that garnet age of 449 dates peak tectonic metamorphism, or occurred right in the middle of the peak, right in the middle of the tectonic orogeny, which again is what we expected to see. But we see no evidence of Akkadian, Neo-Akkadian, and certainly not Alleghenian in this package of rock. So next, we're going to go and view similar age rocks or similar metamorphic age rocks in the Winding Stair and Standing Indian areas